Okay, before I simplify this problem, I want to explain something to you. You know when you're combining like terms, like if I have 2x plus 6x, you take the coefficient, which is the number in front of the variable, and you just add those together. 2 plus 6 would be 8, and then the x just kind of goes along for the ride. It's like saying you got $2 in one pocket and $6 in the other pocket. You've got $8. Or you've got 2 apples here plus 6 apples there. You've got 8 apples. So 2x's plus 6x's is 8x's. This same concept works with radicals. You cannot combine radicals unless you have like radicals. So when I'm looking at this problem up here, right now I see I have 7 square root of 20z plus 1 square root of 45z. I cannot add them together. They're not like terms. Had I had 7 square roots of 2z plus 1 square roots of 2z, then I would have 8 square roots of 2z. Your square root of 2z is your like term. Just like over here, I had 2x's plus 6x's gave me 8x's. If you have 7 square roots of 2z plus 1 square roots of 2z, you've got 8 of those square roots of 2z's altogether. Now, you want to add these together, but you can't because they're not like radicals. However, let's see if we can simplify the radicals so that they can be added together. Okay? So, I'm going to start with the 7 times the square root of 20z. 20 is not a perfect square. However, 20 is the same thing as 4 times 5. 4 is what I like to call a square rootable number. It's actually a perfect square. The square root of 4 is 2. I cannot take the square root of 5, and I also can't take the square root of this z, so this square root of 5z just stays the square root of 5z. But you also have this 7, so don't forget it. Now, once you take the square root of the 4 and get the 2, he is now out from under the radical, and he is free to start hooking up with the 7. And now I'm going to take 7 times 2, and that's 14, but I still have the square root of 5z. That's the first one. Now, I still have this plus sign right here. Here's this plus sign. That's this plus sign. So, all of this right here is what I did to this, simplified it. Now I'm going to come over to the square root of 45z, and I'm going to mess with that. Now 45 is not a perfect square, but 45 is 9 times 5, and 9 is, like I said, square rootable. That's not a real word. That's an Aprillism. I made that up. I can take the square root of 9. The square root of 9 is 3. I cannot take the square root of 5. And this z is still under the radical also. You can't take the square root of him either because he doesn't have an even exponent. So I've still got this square root of 5z here. So I've got 14 square roots of 5z and then 3 square roots of 5z. I took all this and simplified it. All right. And now I can finish the problem because I have 14 square roots of 5z plus 3 square roots of 5z. 14 and 3 would be 17 square roots of 5z. And that's my answer. Now, I know in Mobius it said some other stuff, so let's see. This one does give me the sigma box, so I can do radicals. So I'm going to type that on here. Oh, look at this. A whole bunch of stuff showed up. Wait a minute. Nope, that's something else. Type here and then do this box. That's what I want. Okay, there we go. I know it's not a radical, but if you click on the A to the B, it gives you other options. So we want this square root of A. Hang on just a second. I just want to go back and look at my answer. It was 17 square roots of 5z. I have to type in the 17 first. Then click on this. It's a square root, so I want this one. I would use this one if I was doing cube roots or fourth roots or fifth roots. I got a square root, so just click on that and then just type 5z. And then I got to go up and click on the how did I do and hope for some green. Yay! On this problem, you also have to come down here and it says show your work and explain how you arrived at your answer. There are sample student explanations in the feedbacks to questions, blah, 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 blah. Anyway, if I were doing this, I would literally type in what I just did on that previous page. Let me pause again. Okay, I'm back. I wanted to get a split screen here. I would, let's see. I would type in 7, equation editor. Okay, sorry, forget the 7. Boop, go to equation editor, and this is where I type in all my work. I'd go 7, and then I'd type in the square root of 4, and then another square root of 5z, and then get out of there and put a plus sign, a few more steps, I don't know, and then I put the square root of 9. I'm trying to show my second line here, all in one. Square root of 9, space over, give another square root of 5z, then hit, can I hit return? It won't let me return, will it? No. Okay, so then I got to hit done. Okay, and that typed in the first one, then hit return. I hit return twice, give some space in between. Then the next line would be 7, and then the asterisk times, and then 2, and then the radical, and then 5z. This is fun. And then space, 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 and plus. Oh, oopsie. Shit. So sorry. Sorry. Space over before you, or arrow over before you hit space, space, space. Otherwise, that radical goes with you. Plus, space, space. And then I'm going to go 3. I think you're getting the idea of this, right? It's a little tedious. And then 5z, and then I have to hit done again because it won't let me do a return when I'm in equation editor, but I can return here, you know, and then I type in 14 and blah blah blah. And it also asks for an explanation, and you can verbally write it out too as well if you don't want to mess with the equation editor. But you know, just typing like blah 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 blah. This is what I did. All right, so hopefully that helps you out a little bit.